Cold storage is a method of preserving perishable commodities, including dairy products, in their fresh and wholesome state for an extended period by providing and controlling proper temperature and humidity conditions within the storage compartments. The cold storage is a part of a structure called the chilled water system. The chilled water system is composed of four main parts: the compressor, condenser, evaporator, and expansion valve. These components play an important role in providing a refrigeration system within the unit. The active refrigerants in the system is an R22 refrigerant and the 15% brine solution, which is a solution of sodium chloride in water. The chilled water tank is used as a heat exchanger in the system that will provide heat rejection and cooling through the designated and the cold storage system. The scope of this video is to discuss the system diagram, the thermodynamic theory behind the system, the process of the components involved in the system, and the operation of the chilled water system.
So I will explain to you the main parts of the chilled water system. So here we have the primary breaker of the chilled water system. It is where the chilled water system got all its power. So next is the secondary breaker. The primary breaker has 60 amperes, while the secondary breaker has only 30 amperes. This is the wattmeter that monitors the power consumed by the chilled water system, and this is the main heart of the system. We got the accumulator, the compressor, and the capacitor. Note that the compressor is a hermetically sealed compressor. And there are two pressure gauges that monitors the high side and the low side of the whole system. After you have the compressor, we need to press the solution, the R22, and it will go through an evaporator. Then it will go through an expansion valve, which will go through here, in which the temperature will go down. It will flow through this pipeline to that pump and will go up to the fan coil unit inside the decim nut. If you turn off this, as you can see, it is already turned off. And turn this on, it will go through the cold storage system, in which any food or perishable items will be placed to be cooled.
So the thermodynamic cycle behind the chilled water system is the vapor compression cycle. So the schematic diagram of the chilled water system comprises of the four main components: compressor, condenser, expansion valve, and the evaporator. So the process of 1 to 2 of the compressor is called the isentropic compression. It's isentropic because the entropy is isolated within the TS diagram. The next process is called the isobaric heat rejection, where the condenser rejects the heat inside the system. Isobaric is because the pressure is isolated while the process is being done. Here we can see in the pH diagram the straight line of the condensation. 3 to 4 process is called the isentropic expansion. So the refrigerant inside is expanded so it can be cooled, and then it can be processed next to the isobaric heat addition of the evaporator. So the isentropic expansion is because the enthalpy is isolated, and we can see it here in the pH diagram once again, the straight line. And lastly, the isobaric heat addition is done by the evaporator, where the heat is added once again. So isobaric is because of the straight line of the evaporation from the TS diagram.
For the operation of the chilled water system, before anything else, we will check the power connections of the outside unit. And we will follow the orange insulation of the wires. That one. After following the power line, we proceeded to the materials testing laboratory. And the main breaker is located here. So we will check if the blue wire is connected to the 60 ampere breaker. Here is it. And it is connected. After checking the 60 ampere circuit breaker, now we will proceed to the 30 ampere circuit breaker. We will turn on the circuit breaker. Now it is turned on. And the watt meter will start. It will blink. And the color is red. It will indicate that the unit is operational. Now that the outside unit is turned on, we will proceed here inside the refrigeration room. And we will turn on the circuit breaker. It is a 15 ampere circuit breaker. Before turning on the pump, we should check if all the valves are closed. On the control panel, we can see that we have a refrigerant power switch and a water pump power switch. To turn on the pump, we switch on this button. To operate on the cold storage unit, we will make sure that the brine solution in the chilled water tank reaches its required temperature. Now in the discharge port of the chilled water, we will change the state of the first valve to fully open. Now we will change the state of the valve next to the flow sensor, this one, to fully open. To allow the flow from the chilled water tank into the cold storage, we will change the state of valve number 3 to fully open.
The fan coil unit. To operate the fan coil unit, first, we must change the state of the valve located right after the discharge port of the chilled water tank. We should put it in fully open mode. Next is navigate the valve located between the discharge port of the pump and the flow sensor. Put it in fully open mode. Without opening the valve number 3, you must turn this valve number 4 to fully open mode in order for the chilled water tank to fully flow onto the fan coil unit.
To close the cold storage unit, we must first close the valve number 3, which is connected to the cold storage unit, and afterwards the valve after the T, which is valve number 4, and the discharge line, which is this valve. Now to turn off the fan coil unit, you can press the on button once again to turn off the fan coil unit. Afterwards, you can then unplug the power cord in the fan coil unit.
So we have innovated some pipelines in the system. As you can see, we have fixed the pipelines here. Here we have provided a new valve. The pump, the previous pump, the pipeline were connected by PVC cement. We have used a male adapter reducers in order for the pipeline to be removable and can be easily cleaned, as well as this network connecting to this. Also, we have provided hose so that anyone who will clean the pump can easily remove the pipeline connecting to the fan coil unit and the chilled water tank. Also, we have provided a new water flow sensor because the old one was broken down due to the mixture of corrosion and brine. As you can see, we are testing now the pump. First we applied pressure, water pressure to the hose, which will serve as a jump start in order for the water to flow to the piping network. As you can see, the flow rate of the water is constant. And so this is the first testing after we have prepared the pipings on the chilled water system and also replacing the pump. So as you can see, the compressor, the accumulator are working. Here, you can see the water is already filled in the chilled water system. The chilled water tank pump is working, though it has leaks, in which we will fix later after the presentation. As you can see here, the fan coil unit is already working and is plugged in. It was turned on by this remote. There. As discussed earlier, the problem encountered on the new pipings that it has leaks up until here, below the water flow sensor, going down to the reducers.